I was one of the first people who went to the FAA. You can imagine what that response was. Like, this was back in 2011. Like, hey, I think I'm going to 3D print a metal part and put it on a jet engine. How do you think that conversation went? Not too well.
I'm here today with Lauren Tubising and Mark Shaw with the National Institute for Aviation Research. What are some of the challenges creating headwind?
We don't have all the standards we need. Even though I'm a believer in one standard for qualification, I need material standards for all the materials. Right? I can't, if I just have Inconel 625, what happens if I need steel? What happens if I need aluminum, titanium? And of course, there's some of those out there, but there's not enough. So we need what we call material allowable, design values, and data just to create that baseline so I can perform OQs. I'll speak on behalf of my Department of Defense friends, data rights. Now, I come from an OEM. I understand how money is made on the OEM side, and I understand why there's IP and data rights asserted. But I also know that parts, we have a part problem, a spare part problem. So somehow we need to come to an agreement. I tend to think it's probably rethinking our business model between government. But however that occurs, we need access to data so that when there's an airplane on the ground, we can replace that part as quickly as possible, either through the OEM or through the government. There's been resistance from the regulator community, right? And rightly so. Since I was one of the first people who went to the FAA, you can imagine what that response was. Like, this was back in 2011. Like, hey, I think I'm going to 3D print a metal part and put it on a jet engine. How do you think that conversation went? Not too well. Yeah, I normally have more flowery explanation on what the response was. But it really was just sitting down and talking to them and working through what the concerns are. We're still in those conversations is the point, right? And we have multiple regulators. I mentioned them. We have Air Force, we have Army, Navy, we have FAA, we have the European agency, NASA. They all have different concerns, and we're not to a place yet where it's metal is metal. There's additive. I was asked once, is it the additive part or is it the metal part? I'm like, yes, it's both. So I think those are some of the headwinds. I'll hit one more, maybe this. So economics. The economics are hard. We're buying machines, we're filling factories, we're spending $50 million on machines and factories, and then when I make my first part, guess where all that cost goes? It goes down into the part through depreciation and other means. So the cost basis, the ROI is really, really difficult. Converting technical data is very costly. I've got nearly 100-year-old B-52. When we had 75 or something, whatever number of years it's been flying. How do we convert that to an additive part? Well, it's not cheap because we have to do all the appropriate safety analysis, and on and on. So those are the challenges we know. Maybe we can come back and talk about what we're doing, but I'll just hold my tongue here and let Lauren chime in.
My comment was going to be the economics right now. And it's a little bit of a catch-22, right? Because once we democratize this and it's metal is metal, or maybe additive metal is metal, maybe not fully there, but the industry is printing this. This is something that we leverage quite a bit. The cost will go down. So then people will be more willing to use it because the cost will be comparable. But we're not there yet. So how do you encourage people to use additive when it's more expensive so that in the future it will be less costly? So that's a catch-22. I think a lot of us are in. But you have to invest in that to get to that point.